Very good evening, friends. Welcome back. Welcome back on a Monday morning, all recharged, raring to go for a lot more learning Monday to Friday. And yeah, so the first day of the week and new learnings, new opportunities to move ahead, right? So we are discussing about hyperparameters in our series right now. And today we are going to be discussing about the recommendation system, or the recommender engine, or whatever you choose to call it. That is what we are going to be discussing within that. Now, the recommendation engine itself, the recommendation system itself, is a pretty tricky and also at the same time quite an interesting unsupervised algorithm, wherein on the basis of the available data, on the basis of various attributes that is available to us, we come up with some kind of recommendation. We all know about the fundamentals of that. We have the two primary recommendations, people to people and product to product or item to item recommendations. All those are fine. Now, the hyperparameters within this, what do they do? Are they going to increase the recommendation metric, or they going to increase the, or improve, sorry, I shouldn't say increase, improve the recommendation, or they're going to improve the measurement metric? What is it? Is a slightly gray area. So what I'll do is I'll leave everything to Sharath. Sharath, I want you to just first guide us through the various what shall I say, gray areas, or areas where little more focus can be done, or little more research people can do in recommendation system, because we have at least you have done a lot of projects wherein you found that so many things were lacking. So probably you can address that probably in the first 1/3 of your time, and then we will go into the the hyperparameters of recommender system.
Good evening, everyone. Good evening, Nitin. Good evening, Bernie. Thank you so much for connecting. We are glad to share the knowledge that we have accrued over the years. With respect to recommendation engine, the funny thing is we don't have many readily available Python libraries that we generally use. Every recommendation engine that we try to develop is very, very customized, very dynamic, and it purely depends on the requirements specific to that particular business case, and the recommendation engine strategy is directly proportionate to the management's discretion. So we always try customized libraries. We develop the logic based on the requirements for recommendation engine. And right, in fact, the recommendation engine logics keep changing because what strategy today is working may not work for tomorrow's business cases. So it is very dynamic, and the custom functions that we write are designed in such a way that the scope for these changes are also made available. Like you pointed out, the recommendation engines predominantly can be seen as customer to customer similarity based mappings, or we can also try and do item to item similarity mapping. But ultimately, the idea is to personalize the options that we are trying to give to the end user based on what they have already did, that whatever the transactions that they performed. But the important point is we will not have any additional information to personalize things for the customer. The only data that we will have is the transactional data. If we can get any secondary data which can tell more about the customers or the entities, then using that secondary data, we can try and develop much more personalization, the logic that can be implemented. But again, saying that, we need to figure out the logic, and custom programs have to be written. Though we will be looking into some libraries, one of the library which is kind of being used nowadays is called as Surprise. The Surprise library is basically a scikit-learn library, and it's basically called as Simple Python Recommendation System Engine. surprise. Now, this surprise library comes with different strategies within it. We also have auto surprise library, which also is kind of an auto EDA logic, but it is still under development. It is not completely evolved. The surprise library that we are talking about has many variations of recommendations that we can, recommendation engine strategies that we can apply. One of that is your SVD logic, which Netflix uses for its recommendation engine. We do have variants in SVD techniques. We have K-NN basic. K-NN, this is basically the distance-based logic. For identifying the similarities, we use cluster logic also. So likewise, we have different variations or different options that we can choose and implement in surprise library. So that is one package you might want to look out for. But as I said, right, everything is more of a personalized strategies that we have to design.
All right. Thank you. Thank you, Sharad. So, Barney, anything you would like to add about the challenges when dealing with recommendation system projects, and not only on the scope of hyperparameters, but what are the methods? See, the objective of hyperparameter is to improve the model, whether it is with reference to accuracy or the metric itself, the model's quality itself. That is the objective. So directly, we have hyperparameters for many of the algorithms. So anything indirectly also that you could probably have used to improve the overall accuracy or the quality of the recommendation. What is your take on that?
Yeah, absolutely, Nitin. So the biggest challenge with respect to building a recommendation engine is to figure out to what extent you might want to go. What do I mean by that? You know what, people, when they watch movies, for example, on any of the OTTs, it could be Amazon Prime Videos, or it could be Hotstar, or it could be Netflix, or any other OTT. Usually, they don't do that in silos. For example, I'm going to switch off my mobile. I'll put my mobile aside. I'll just watch this movie. I mean, not many people do that. While they are watching, a lot of millennials are actually, exploring, or they usually explore social media forums. Even I do so. Multitasking is something which people do. And since you do multitasking, there are high chances that if I were to capture your social media data also, then real time, probably I can do predictions with respect to what kind of movie you might like. Okay, so, and what kind of movie you might want to recommend to your friends as well, so that the recommendation doesn't restrict at your end. What is the purpose, main purpose of recommending? The main purpose of recommending the products or movies is to ensure that you either purchase that product or watch that movie, so that you get latched on to probably Amazon Prime Videos, right? As an example. And if in the due course, if you're also going to recommend that to your friends on social media, wow, nothing like that. However, you need to, go that extra mile. The deeper you go into analysis, better would be the recommendations. Having said that, it would be a costly affair once again, because you need to pay probably to, Facebook or LinkedIn to get the data. Is the amount of money that you're paying worth it? Are the number of subscribers renewing their subscription at the end of 1 month or 1 year? Okay. And are these people recommending your products to other people as well? So these are a few things where challenges arise. Alongside that, challenges arise with respect to the personalization. To what extent do I need to personalize? Sometimes, given the scenarios, if you have new customers or if you have new products, I mean, whom would you recommend? Or if you have new people who have just subscribed to Netflix, what movies are you going to recommend? Right? In that scenario, it will be non-personalized. So that means most popular content is what you might want to recommend. Then you have again semi-personalized recommendation. In semi-personalized, you probably create different segments, different groups. And then in each group, for each group, based on their liking, you recommend certain things. Then you have based on the personalization, that is, on a Monday morning, what movie would you like? Versus on a Wednesday evening, what kind of a movie would you like? Versus on Friday evening, what kind of a movie would you actually like? Well, all these are one part of it. Privacy comes into picture as well. When we try to install certain applications like mobile app, you must be having Amazon Prime or Hotstar or Sony Live or whatever, or Netflix, etc. When the moment you install that app on your mobile, it would, or on your desktop, if you were to install that particular application, they will start capturing a lot of data. For example, maybe all of your contacts that you have, or maybe the kind of browsing that you have done. While they say that we are not going to share this with anyone, we never know because a lot of data is getting hacked and organizations are moving towards data monetization strategies. Whom will they sell that for to? We really are not sure. So these are few challenges that people see, and then also with respect to accuracy and explainability, there's huge issue there. Do you want quality of recommendations or explainability? What is more important? Why are you even recommending that? If you look at Netflix, we are recommending these because you watch these movies. These are generic recommendations. In that way, you see that. Okay, and also challenge lies in selecting the appropriate algorithm. If you ask me, let me quickly share my screen.
Yeah, while you're
So if you
sharing
look
the screen, Bernie, just a quick anecdote that I would like to add that happened with me. So within the platform, for instance, YouTube and Google, all right. So it is perfectly understandable. I'm watching a YouTube video, which is basically clips of famous cartoon movies. I love cartoon movies. I'm still young at heart, so I'm watching a small clip of important scenes from cartoon movies, and suddenly I want to know who this character is. Now, ideally, if I hadn't paused my YouTube video to go to Google and search, the next YouTube video would have been something similar, would have been, another cartoon video of similar genre or whatever. Now, because I paused my YouTube, I went to Google Chrome on my mobile phone, searched for voice of this particular character in this particular movie, and I came to, oh, this guy. Then I read a little bit about him. Oh, this fellow's got an interesting voice and seems to be a good actor. Coming back to YouTube, I get recommendations not on the cartoon movies, but of that actor because it is essentially the same platform. So maybe you would like to touch upon what if I'm on Netflix and I want to do a little Google search. Do you think that Google will share information to Netflix and then not immediately, but eventually recommendations will come that this person in your specific movie was looking at a specific co-actor or a villain role and maybe recommendations of that? I mean, what is your take on that?
Today, no wonder, and arguably Google is the best search engine, and they have monopoly in the market. Though we have Microsoft, Bing, and Baidu from China, etc., Tencent. That's not oligopoly. It is monopoly at the end of the day. And Netflix also wants to market. When someone says that I want to, watch a specific movie, then Netflix also would want to perform some kind of search engine optimization so that their details appear at the top of the Google search. So that means there is some exchange going on. And Google Chrome, while it is very lightweight, the moment you install, you're agreeing that whatever you browse would be captured by Google. Simple. And what does Google want to do? Do they want to monetize that or just capture, store it in their database? It's a cost. They need to save it in their data centers. So they want to obviously monetize that. And this is exactly how they would monetize, by selling the data to the companies, etc. How much ever they speak on the face of it, some amount of data monetization happens.
Just to add a point on top of that, all these applications that we are installing, whether on your television or whether on your mobile application, mobile phone, you will have to agree on terms and conditions that these applications are going to ask you. Without even reading them, we agree. So ultimately, the cookies that are getting stored on your device basically are accessed by all these applications, irrespective of what platform you're working on and what software you're having on the system. That gives a lot of data exchange for these different applications, and thereby they capture all the information that is required for them to build these customized recommendations.
Yeah, sorry, I think we are a little bit digressing, so I'll just wrap it up by adding one more point. So the big organizations, the FANG, as we call them, the big organizations who are amongst themselves sharing and giving data, ultimately, while they are monetizing and making money out of that, the services that they are rendering towards the users. Now, if the recommendation is simply amazing, that is probably the reason why people are losing their sleep over it and watching YouTube videos when they're supposed to be asleep. The recommendation is amazing. That is why people try to finish the entire series of a particular. There are hundreds of thousands of series. How does the right web series come to my recommendation based on the basis of my preferences? Is an amazing thing as it is. All right, and for that, they are taking the data. For that, they are using my browsing history and giving me that information. I think majority of the people will be okay with it. And also, it is not about clandestinely or illegally being done. We have actually agreed to that. So intellectuals or the other forum of people will say, people are taking your data. They said, I'm going to take your data. They said, I'll use your data to, improve your viewing experience and all the recommendations. And that is where we are. So caveat emptor, there's a very famous expression that I like to use, buyer beware. So there's no free lunch. We are the lunch. So yeah, let's get back to the topic. Sorry, Barney, I kind of get segregating on these things. Yeah.
No problem. So building a recommendation engine is no small task. It requires thorough planning in the first place on what kind of data you would be looking at in order to do recommendation, and what kind of algorithms you will use. To what extent will privacy be safeguarded? All these things are extremely important. And if people feel that, there is a dating website and recommendations are happening for me, then, that data for most people is very private. Even what kind of movies they watch is very private. So how do you safeguard that data? Using some kind of factorization techniques, right? Like S3D or PCA, etc. Alongside that, what kind of algorithm? What kind of algorithm you want to choose is also extremely important. Is it content-based algorithm? Is it collaborative filtering? Is it memory-based approach or model-based approach? When it comes to memory-based, you have user-based, item-based filtering techniques. When it comes to latent factor-based, you have clustering-based. You first perform clusters like k-means clustering. And for each cluster, you're going to do some recommendation. It's semi-personalized. You have matrix factorization based algorithms where to a great extent, data and privacy is safeguarded. And there are also deep learning and neural network algorithms which are being used. And when you use deep learning neural network, everything is black box, right? So completely your data is safeguarded. So explainability versus privacy, you can also look at that aspect. You lose explainability, but at the expense of safeguarding the privacy. So in a lot of dating websites, etc., people use deep learning neural network kind of algorithms. Even in matchmaking websites such as shadi.com, etc., people use neural network algorithms. And you can also use hybrid algorithm, which would be combination of content-based and collaborative filtering. There is also demographic filtering based on your demography. It's more of non-personalized recommendation. And then you have something called as knowledge-based filtering. Knowledge-based filtering means if you leave a review of a specific movie, what kind of review did you leave? Right? Is it positive review or negative review, or what kind of emotions are you exhibiting? And based on that, can I recommend a movie? Yes, absolutely, you can. Right? So if you're not at all rating, a lot of people, what they do is if they don't like it, they feel that, it's not even worth rating because they want to rate probably 0 or negative value, but negative doesn't exist in rating. It's 1 star or 5 star, right? So people are like, there's no negative rating, so let me leave it. A lot of people do that. So from that, what knowledge do you glean? How are you going to use that in building your algorithm, right? So all these are the various things that one has to think through even before building recommendation engine. Yeah. Thank you, Nitin. Over to you.
Thank you, Bernie, for that detailed explanation there about the various aspects to recommendation and the methods of doing it. Yeah. So I'd like to, quickly wrap it up a little more about. I'd like to quickly wrap it up a little more technical because your knowledge of the generic or the general knowledge or the current affairs with reference to recommendation, etc., is not something that interviewers are keen on. They are more interested in how probably in their small systems you will be, we're not looking at the FANG, we're not looking at Google, and they already have pretty much advanced recommendation systems. So a small organization which is, working in the social media space, trying to do that. How do we work on that? So what are the libraries? What are the aspects that a person trying to work in the space of recommendation engine it is? All right. Can you please, address on that aspect, Sharath?
Sure, definitely. As I already spoke about one library, which is Surprise. It basically defines. These libraries are depending on some strategies, matrix factorizations, or you basically, as Bernie spoke about, similarity based, knowledge based. So these are all predefined. The logic is predefined, but these Python libraries allow us to experiment on these different strategies and try to also do the predictions of recommendations. And there are libraries which also have metrics which allow us to evaluate whether the recommendation that we are giving is appropriate or not. So along with Surprise, I would also try to bring up certain libraries like TensorFlow recommendation. We also have recommendation metrics, CRAB. Then we have LensKit. LensKit is again one of the popular open source library which is there in the industry being used by many. Then we have Rexy. Rexy is again a very big recommendation engine platform or library. You can try and look into the documentation in PyPI GitHub repository itself. Right, and these are all not so evolved libraries, but they are these libraries which are kind of being standardized now. All of them are either user based or your item based, right? And we also have Tensor recommendation engine, as I already mentioned. We have something called as Light FM. We have Spotlight. We have Case Recommender. So many such libraries are readily available for us to experiment on our recommendation engines. In fact, I would also talk about the benchmarkings. So the recommendation engine frameworks are there, which are used as benchmarking systems. One of that is a tag recommender system or tag recommender benchmarking system. These are also used heavily. And in media, right, this is very, very important. In media, a lot of libraries are used. One of the movie recommendation site, that is Genie. This is also used as one of the standards. And yeah, as I mentioned, there's a huge list of libraries that we can actually use. Mahout is there, which is very, very popular library on Hadoop platform, distributed engine platform. But all these flexibilities that are available, the most important thing that we need to look at is whether a given standard or whether a given strategy is applicable for our business case, right? And we need to ultimately do experimentations, use these recommendation engine metrics. There's one specific library called REC metrics, recommendation engine metrics. This would also help us to evaluate whether the recommendations that we are doing are appropriate or not. So we experiment, we evaluate the recommendation engine strategy that we implemented, and thereby, right, rigmarole happens, and then we choose the best recommendation engine for our given case. And not to forget the cloud platforms. There are a lot of readily available recommendation engines solutions that are made available on our cloud platforms. Whether you name it, whether it is AWS, whether it is Azure, or the GCP being the top 3 cloud platforms, there are customized recommendation engine services which are provided as a platform, or you can say software as a service. Sorry, not platform, but yeah, software as a service. You can try and experiment these readily available solutions as well. So these are small insights from a technical perspective. You might want to also look into these solutions. One specific library I would want to, or service that I would want to bring up here, which basically is a solution which was developed as part of Netflix competition. Netflix tries to launch these competitions to improve their recommendation engine. It's more like a hackathon. And one organization called Gravity R&D, this is basically now is made available as a solution, software as a solution. You might want to look into that option as well. It is a very good solution. It has won the prize in Netflix recommendation engine competitions. So yeah, it's just an exploration away. You can try and find a lot of readily available solutions for recommendation engine.
Thank you, Sharath. So yeah, audience, as far as recommendation engine goes in laboratory settings, unless and until you have the really heavy infrastructure available, one cannot really claim to have worked with extensively with recommendation engines and actually seen the production kind of a setup. All right, because you need to be part of a really good-sized organization to apply those recommendations to see how it works, because the amount of data that is required is humongous. But how to compensate for that is is basically to know more about the available theories that are there. Like Sharath was rattling off the names of so many libraries and so many and also the anecdotes around them, what prizes and what all the things they have done, and etc. All right, so these are some of the things that you could probably compensate with when you are dealing specifically with recommender systems. Unlike probably in a supervised algorithm where you can delve deep, even with 20 records, you can probably try just about everything. All right, but not so in this particular case. So yeah, the strategy of learning for recommendation system is going to be slightly different. So on that note, we'll wrap it up. I hope you had an enjoyable and a highly informative session today with the recommender systems and the various ways to improve the algorithms. Thank you so much. And yeah, please do help us increase the numbers. And yeah, anything to add, Barney?
Nothing. Thank you so much, friends. Just share it with your friends, relatives, known associates, and let them like, share, comment. Thank you. Thank you so much. Bye.
Thank you, friends.